Hi friends, this is Sujata, Associate Professor working at Government College for Women, Kolar. And this presentation is made for the benefit of final BSc students belonging to Bangalore North University. And this is paper 5, Organic Chemistry. And this is session 25 of the topic Chemistry of Natural Products. And the subtitle is Terpenes and Terpenoids. In the previous session, you might have learnt about the occurrence and classification of terpenes and terpenoids. And in this session, let's see what you're going to learn. The objectives of this session is to understand the experimental facts behind the elucidation of structure of a-Citral and its synthesis from methyl heptenone, and also elucidation of structure of Zingiberene and its synthesis from para-methoxy methyl magnesium bromide. To understand this session, one should have the knowledge about the characteristic reactions of aldehydes such as condensation reactions, addition reactions, and so on, and process of ozonolysis, wherein the ozone is added across double bonds and cleavage occurs, and reformats A reaction, which is true for carbonyl compounds, where carbonyl compounds react with alpha halogenated ester in presence of zinc to give beta hydroxy acids, which you are going to see later. So when you understand the session, you should be in a position to understand the facts about the elucidation of structure of a-Citral and how it is synthesized from methyl heptenone. Similarly, the structural elucidation of synthesis of gingiberine and its synthesis from para-methoxy methyl magnesium bromide. Here are the facts that are basis for the structural elucidation of a-Citral. Usually the molecular formula is based on the elemental analysis and the molecular weight determinations, and it is found that C10H16O is the molecular formula of a-Citral, that it contains 10 carbon atoms, 16 hydrogen atoms and an oxygen atom. Citral, when reacts with hydroxylamine, it forms an oxime. It adds on sodium bisulfite and gives an addition product. All these reactions are true for carbonyl compounds. On reduction with the sodium amalgam in water, it gives geraniol, a primary alcohol, and thus on oxidation in presence of silver oxide forms geranic acid. So this clearly confirms the presence of aldehydic group in the molecule. Further, on ozonolysis, citral gives acetone, glyoxal and levulinaldehyde. This indicates, here you can see, when it is subjected to ozonolysis, three important products are obtained: acetone, glyoxal and levulinaldehyde. So these indicate the presence of three double bonds in a molecule. Here we can see the location of double bonds later. On heating with potassium bisulfate, citral forms paracymene. This indicates the position of methyl and isopropyl groups. Here, this is the isopropyl group. Here is the methyl group. These two positions in citral are indicated by this reaction. And from the evidences, the structure of citral is, here you can see, two double bonds. This is the isopropyl group and here is the methyl group, and it contains an aldehydic group. Further, we shall look into the steps involved in the synthesis of a-Citral from methyl heptenone. First reaction is heptenone is subjected to reformatsky reaction. As we understood earlier, reformatsky reaction is true for the carbonyl compounds, wherein the alpha halogenated ester in presence of zinc leads to the formation of beta hydroxy acid. This beta hydroxy acid is dehydrated in presence of acetic anhydride to get uranic acid, and the calcium salt of uranic acid is heated with calcium formate to give citral. So this is as good as the preparation of general aldehydes. Now let us get into the facts that are basis for the elucidation of structure of zingiberene, which is a monocyclic sesquiterpene that occurs in the oil of ginger. We are all familiar with ginger and its pleasant appetizing flavor. This submolecule zingiberene is optically active and it is levorotatory in nature. Now we shall look into the facts about the structural elucidation. First being the molecular formula. Elemental analysis and the molecular weight determinations on zingiberene showed that the molecular formula is C15NH24. It contains 15 carbon atoms and 24 hydrogen atoms. It is purely a terpene, while the alpha-Citral is a terpenoid because it contains oxygen atom. Second, an important reaction is the catalytic hydrogenation of zingiberene leads to the formation of hexahydrozingiberene. This reaction shows that the one molecule of zingiberene consumes 3 molecules of hydrogen. So therefore it shows that it contains 3 double bonds in it. When it is reduced with sodium in ethanol, it produces dihydrozingiberene, showing that it is a conjugated cyclic diene. It means one double bond is present outside the ring and 2 bonds, that is conjugated diene, is present inside the cyclic ring. Further, on ozonolysis, zingiberene gives 3 compounds: acetone, succinic acid and levulinic acid. Formation of acetone indicates that one double bond is present outside the ring, and formation of these 2 indicate that the 2 double bonds, more double bonds, are in the form of conjugated diene. When zingiberene is subjected to Diels-Alder reaction with methyl acetylene dicarboxylate, it forms a dicyclic adduct which upon heating gives 3,7-dimethyl octa-1,6 diene and methyl 4-methyl phthalate. Here you can see this is methyl 4-methyl phthalate, and here we have 3,7-dimethyl octa-1,6 diene. So from these evidences, the structural formula for zingiberene is it is a monocyclic sesquiterpene containing 3 double bonds. Here are the steps involved in the synthesis of zingiberene from para-methoxy, phenyl magnesium bromide and methyl heptenone. Here is the main reactant, para-methoxy, phenyl magnesium bromide. When it reacts with methyl heptenone and upon protonation, it forms a tertiary alcohol. This, when loses a molecule of water, this induces a double bond in the molecule, and this intermediate, when subjected to Birch reduction, gives another intermediate wherein you can see there is a change in the positions of double bond here, that is rearrangement in the pi electrons, and this molecule when protonated it gives cyclohexenone, and this cyclohexenone when reacts with methyl magnesium bromide, the Grignard reagent, Again, it forms a tertiary alcohol which, when subjected to dehydration in presence of oxalic acid, gives rise to zingiberene. Now, in this session, you all have understood the facts about the structural elucidation of a-Citral and zingiberene, and also the synthesis of a-Citral and zingiberene. Coming to the multiple choice questions. Molecular formula of citral is C10H16O. Which among the following are formed when citral undergoes ozonolysis? So, the right answer is C. It forms acetone, glyoxal and levulinic acid. And to name the reaction that converts methyl heptenone to beta hydroxy acid during the synthesis of citral, it is Reformatsky reaction. As we know, zingiberene is a monocyclic sesquiterpene, and when zingiberene is reduced in presence of sodium in ethanol, dihydroxyzingiberene is obtained. This shows that zingiberene is cyclic conjugated diene. Hope you understood this session and it is informative. Thank you.